Okay, so in this case, we've got Ba₃N₂, which is in effect barium nitride, reacting with H₂O, and the H₂O is said to be in excess, and this produces, in this particular case, it produces BaOH2 and NH3, right? Okay, and we've been asked to calculate the volume occupied at room temperature and pressure, specifically by the NH3 produced, right? And the information we've been given is that is that 1 mole of any gas occupies a volume of 24 decimeters cubed at room temperature and pressure. That will become much more relevant later on as we're working through this. At the moment, but it's just relevant information nonetheless. Okay, so how am I going to approach this? Well, I'm going to want to be able to figure out as the primary objective initially is, well, to be able to work out the volume occupied, I need the amount of substance. I need the amount of moles, basically, of the NH3, right? Once we work that out, I mean, the next step is relatively straightforward, but we do need to work that out. So I'm gonna have a go at working that out, and then we'll go from there. Okay, so for the Ba₃N₂, we've been given the mass that actually reacts, and we've been effectively told by the question saying it reacts with H₂O being in excess. You know that Ba₃N₂ is the limiting reagent, which is valuable because that means that the amount of NH3 produced is basically going to be determined by the mass of Ba₃N₂. Okay, so if we work out the amount of substance of the Ba₃N₂, we can then use, the balance equation to help us to work out the moles of the NH3. So let's go about that process. So we know that the mass is equal to the number of moles multiplied by the molar mass, right? Now, if you divide both sides by molar mass, divide by mR here, divide by mR here, right? The mRs then cancel on this side, and we get that the number of moles is equal to the mass divided by the molar mass, right? And in this case, we're looking specifically at the number of moles for Ba₃N₂, right? So for the mass, we've got that in the question. That's going to be 17.46. Now, for the molar mass, we've been told the formula in the question, but we haven't been directly told the molar mass. So we will need to refer to the periodic table to work out the molar mass, which I'm going to try and do now. So, this is for trying to work out the molar mass of Ba₃N₂, right? Okay. If we take a look at barium, what we find is the relative atomic mass is 137.3, right? So barium over here. So that's going to equal 137.3. Because we've got 3 here, we actually have to multiply this by 3. Okay. And then in the case of the nitrogen, that's in effect going to be times 2, right? So if we look for the relative atomic mass of nitrogen, as you can see, we've got 14 here. So it's going to be effectively 14 multiplied by 2, right? Okay, so if you do have a go working this out, you should be able to get what the what the molar mass is, right? Okay, so if you did work that out, what you should have found is you got 439.9, and that's going to be in grams per mole, right? Grams per mole. And So if we actually take a look here, wait, so if I just, yeah, so let me actually write that here just so you have clarity. 439.9, right? So we did need to actually run that calculation, right? So the number of moles of the Ba₃N₂ is therefore going to be equal to, and remember that was grams, right? So just for the mass, and then that's grams per mole. 17.46 divided by 439.9, right? And yeah, so if you work that out, you should be able to get moles for the Ba₃N₂. So that's going to give you 0.0396908, right? And that's going to be in moles. And this is going to be the moles for the Ba₃N₂. Okay, but remember, I said the initial goal was to work out the number of moles of NH3, which we haven't done yet, right? So the next step to try and figure that out would be taking a look at the ratio in the equation. So what we can see, we don't have a visible coefficient for the Ba₃N₂, which implies that the coefficient is 1, right? In effect, for every when we compare the number of moles of the Ba₃N₂ to the number of moles of NH3, in effect we get we've got 1 mole, and for every 1 mole of the Ba₃N₂, as the equation shows us, we've got 2 moles of NH3. Okay, and so what does that tell us? Well, in effect, what it tells us is that for every mole of Ba₃N₂, we have 2 moles of the NH3, and I mean, because the value on usually I would try and get the value on the left hand side to be 1. It is already 1, right? So we can just kind of go to the overall deduction from this, which is the fact that we can deduce that the moles of NH3 is equal to 2 multiplied by the number of moles of Ba₃N₂, right? And we have this value, right? So therefore the number of moles of NH3 is equal to 0.0396908 moles, right? Yeah, no, wait. Multiplied, yeah. We need to do the actual rest of it. Multiplied by 2. Yep. Okay. So yeah, if you have a go at the actual, have a go at that and see what you get. But you should find that you get 0.0793817 as the moles for NH3, right? Okay, so we've made quite a bit of progress at this stage, but we still need to actually, even though we achieved that kind of the initial, the amount of substance goal, we still need to achieve the volume goal. So we still need to work out, well, what's the actual volume of what's the volume occupied by the NH3, right? And this is where the information we were provided with earlier on becomes more relevant, where 1 mole of any gas occupies a volume of 24 decimeters cubed, right? So if we take the 24 and multiplied by the moles we have, we're going to be able to work out the volume occupied. So effectively, so the number of moles, no, not the number of moles, we've kind of done that part actually, the volume now. So the volume V of NH3 is equal to 24 multiplied by 0.0793817. Okay, and that's effectively going to give us 1.905 1608. Okay, and that's going to be in decimeters cubed. Right. Now, this gets us closer to the answer, but we have been specifically asked to give our answer to a maximum of 2 decimal places, right? So we do need to do that. And so if we round this to 2 decimal places, we're going to get 1.9, and then we need to round that up. So it's going to be 1.91. That's going to be in decimeters cubed. So we can say that's to 2 decimal places. All right. So in this particular case, this is the volume which we're going to get.